So 29. First, find two lines other than YD and YF that are perpendicular. Then write a two-column proof that the lines are perpendicular. Given YD is perpendicular to YF, measure of angle. Can you put a pin in this one? I'm just going to put a pin in it. I'm not going to ask anything like that on the test. This is more like a challenge type question. If you got it, awesome. If it was just a really tough beast and you didn't get it at all, I'm okay with that either. It was more like a challenge question than anything else. If you got it, you really get proofs. If not, don't worry about it. So maybe put a little symbol next to it, like don't worry about it. Other questions besides 29? So Sabrina, 29 is out. We're not worried about 29. Okay.
Okay, and
Yeah.
Number 20.
Oh, I'm gonna go to someone else and I'll come back if you. Did anyone else have a question? I just saw a bunch of hands up go up first. We answered yours then? All right, Sabrina, other one.
Number 26.
26. All right. This has got to be our last one. If you still have questions, please put it in the little question box. 26. Says, what can you conclude from the information given? So it says angle B bisects DAC. So this is a right angle. So this is kind of a tough question because they're asking how much information can you just give me. And then it says that CB, did I do the right one? AB, oh no. AB bisects, I was reading the wrong one. All right, AB bisects DAC. So that means angle 1 is congruent to angle 2. That's the definition of bisecting. And then it says angle CB bisects ECA. So what that's telling me is that 4 is congruent to 3. Then it says measure of angle 2 is 45 degrees. So measure of angle 2 is 45. What color should I use? Purple? Let's use purple. So this is 45 degrees. And then it says angle 3 is also 45 degrees. They're asking as much information as we can deduce from this. So what's the measure of angle 1? Yeah.
45 degrees.
What's 45 plus 45? 90 degrees. So these two things are complementary. So we know these two angles are complementary. They add up to 90 degrees. If these are 90 degrees, that means that DA is perpendicular to AC. All right, so they wanted to lead you to that. All right, they want to lead you to this is 45, and once you have a 90 degree angle, you have perpendicular lines. Same thing over here. This is 45, this is 45, so this whole thing is 90. So this line must be perpendicular to that line. All right, they're basically just looking for perpendicular. We're looking for perpendicular would be the big thing that I want to pull from that. All right, because anytime I'd have a proof like this, I would give you those two angles and I would say prove that they're perpendicular. And that's how you'd prove it. You'd be like, that's congruent to that. They equal 90 degrees. They're complementary. If they're complementary and they equal 90, it must be perpendicular. All right? Does that make sense, Sabrina? Okay. All right, let's go on to today's lesson. Well, today's lesson is a bunch of proofs. And what time is this class over at? We are done at 50? Yeah, about 50. Let's take about 10 minutes and try these proofs. You can either work on the one says, in each exercise, use the information given to conclude that two angles are congruent. So we have to, in the end, say these two angles are congruent. And then it says, name or state the definition or theorem that justifies your conclusion. So what they're basically saying is if this statement's true, if angle 6 is complementary to angle 10, and angle 7 is complementary to angle 10, we can actually conclude that angle 6 is congruent to angle 7. And that is because we have a theorem. We have a theorem that says if two angles are congruent to the same angle, then they are complementary to the same angle, they are congruent. So if you take out your theorem sheet, it'd be your chapter 2 theorem sheet. And if you look at theorem 2.8, and you read that one, you're going to see that matches this exact thing. Because 2.8 reads, if two angles are complements of congruent angles or the same angle, then the two angles are congruent. Well, guess what? We have two angles that are complements to the same angle. So for each of these, you're just going to say these two things are congruent for either, it's either going to be a theorem or a postulate. All right, so our next one probably isn't a big theorem. In fact, the next one's kind of a dud. It's just definition of congruent angles, because it's just, they're both equal to the same thing. All right, but that's if you get to those. It's okay if we didn't get to those last questions. We'll get to those as a class. We got a little time.
So then we know that
I'm just going to take pictures of mine.
supplement 4 is
All right, let's go to our proofs real quick. We'll go to those. Ladies, we'll get to those.
Okay.
I just want to go through these proofs, make sure everything matches up. All right, the first one's given. Then we use the definition of complementary angle. So I'm given something, and I unpack it. I unpack what it means. All right? I unpack what it means. And then I said measure of angle 2 is 74. We got that from the given. Well, I replaced measure of angle 2 with 74, so that should have been substitution. And finally, I subtracted 74 from both sides to do my subtraction. Good on that? Yes.
Put down angle addition for number 2.
For number 2, remember, it could be either one of them. It could be angle addition, so you didn't need to change anything, because technically it is angle addition. And I used the fact that they're complementary in one step. So I wouldn't take off points for either one of those explanations. So if you guys didn't hear it, she said, what about angle addition postulate? If you had that, you're good. All right. I just went with complementary because then you can actually see what's being unpacked. All right. All right, our next one. All we know is that angle 1 and angle 2 are supplementary, and we need to prove that measure of angle 2 equals a 145, or no, we're also given that it equals 145. Prove that measure of angle 1 equals 34. Well, that makes sense, because just working backwards is 180 minus 35, which would give me that. But we should have did angle 1, and remember, it doesn't have to be exactly the same as yours. All right, if something's different, just let me know. Angle 1 and angle 2 are supplementary. Given, I unpacked it, and I either said that these two angles equaled 180 because of the definition of supplementary angles, or you might have did angle addition postulate. All right, then I said measure of angle 2 is 145. That was given. Measure of angle 1 plus 145, substitution. And finally, I'm going to use my subtraction property of equality to finish it off. Matches all yours? Questions, comments, concerns? No? All right. Then we'll just do the last one. So last one says, given that 2 times AB equals AC, prove that AB equals BC. So I just state my given, and there's not really much I can unpack from this except for the AB plus AB equals AC. So since I can't really unpack it, I'm probably going to use some kind of addition postulate or something else, and that's what we did. I want to get that total length, AC, and I just did segment addition postulate. Then our next one was substitution. I want to substitute that in for AC. Then we use our subtraction postulate to move the AB to the other side. And then finally, this one can either be distributive or combining like terms. Not overly concerned how you do that because we didn't really talk about that directly. It is the reverse of distributive property kind of thing, but not worried about what you say for that one. Remember, I gave you these, I'm more concerned about these than about your reasoning. So if you're on the test and you're like, I know this is all good, I just forget what reason it is, you'll get more points for having this right than you think you will. Yes?
In the last one, we also put like subtraction.
Yeah, subtraction, basic subtraction, right? That's kind of combining like terms, we
Yeah.
just subtract or add. Alright, we're good on those three? Okay. Then let's just talk about these really quick. We have about 10 minutes. I did the first one with you. I talked about the second one. The second one's kind of a dud of an answer. It really is. So if they equal the same measure, measure angle 5 must equal measure of angle 7. I'm going to give you the answer because it's a boring one. It's just definition of congruent angles. Yes?
So on our test, would it take points off if we don't put like measure of angle 5? If we just like do angle 5?
Probably not. But the more correct way to use just angle 5 and angle 7 is to do this. So if you like just writing this, just put the congruent symbol. So if you like to drop off these measures, just use the congruent symbol and it means the same thing. Grace?
I put like what theorem 2.8 again?
Theorem 2.8.
Because like the first one, because they were both equal to the same. Like,
Yeah, that would work too. I'd be okay with 2.8. I'd be okay with 2.8 on that one. Alright. But you could use definition on that one because it gave you a definite measure. And that's the definition of congruent. If they are the same measure, then they're good. But I can completely see why 2.8 is, because they're comparing it to the same angle, right? Yep, I could definitely see theorem 2.8. And in fact, if you want to, I'd write down theorem 2.8 to do both of them. Because on a test, if you write down two things, I'll probably take the better of the two answers. Unless you write down every single theorem and postulate on every one of them. Just as a catch-all. I'm just going to write them all down. Mr. Pay will never know. Alright, the next one says that AB is perpendicular to CD. Yeah, Sabrina.
Definition of perpendicular?
Close. Close. Well, first we have to list our two angles. So if AB is perpendicular to CD, that must mean that angle 8 is congruent to angle 9. And there is in fact a theorem that specifically talks about perpendicular angles creating two congruent angles. Yeah?
Is it theorem 2.4?
It is theorem 2.4. So every time I give a theorem like that, I would turn to my theorem page and read it. Alright, so I'll give you all a second. If you didn't get that answer, turn to your theorem sheet and look at 2.4. And make sure you agree with Robin. Alright? And in fact, I'll read it along with you. So 2.4 says, if two lines are perpendicular, okay, it does say that two lines are perpendicular, then they form congruent adjacent angles. Yep, they are congruent adjacent angles. So that is going to be theorem 2.4. So before you jump to definition, just give a quick rundown of all your theorems to make sure it doesn't fit in any of those boxes. And if it doesn't, then go theorem. Go definition. All right, xz bisects wxy. Lydia.
What?
Oh, I thought you raised your hand.
No, I was going like that.
I'm still calling on Lydia.
Okay.
We'll work through it together, okay?
Okay.
So not to put you on the spot, but xz wxy, so we find xz wx. I just need to know which two angles are congruent then.
Oh. 6 and 7.
6 and 7. That wasn't so bad, right?
Okay.
Angle 6 is congruent to angle 7. And I'm going to tell you right now, this is a boring one. So who thinks they know why? Yeah, Hannah. Is it 2-1? That 2-1 is a midpoint theorem. 2-1 says if M is the midpoint of AB. Do we have midpoints?
Sorry, I'm losing my voice.
Okay, that's okay. But does 2-1 match when I say it's the midpoint theorem?
No, I was thinking the bisecting is the same.
Oh, okay. Gotcha. It is not. Amber.
Definition of bisect.
Just definition of bisector. You actually don't have one that specifies. Robin, did you have one?
I put theorem 2 too.
Looks like I got 2-2. Maybe you can fit it. Angle bisector theorem. If BC bisects of... so I could see this one. But for theorem... everyone look at theorem 2-2. They have half angles in there. You're looking for... If I give you something that it actually says 1/2. All right, if you see 1/2, then we're going to be using 2-2. On a test, I probably wouldn't take any points off because it basically gets to the heart of definition of bisecting angles. So Robin, you'd be fine with that. Bisecting angles. All right, our last one says angle 4 is supplementary to angle 6. It says angle 2 is supplementary to angle 7. And it says angle 6 is congruent to angle 7. What two angles are congruent, Grace?
Measure of angle. You say measure of angle 4 is congruent to measure of angle 7.
Angle 4. Say that again? So you're saying measure of angle 4 is congruent to angle 7?
Like it adds up to 180.
Oh, that's true. I'm looking for which ones are congruent, though. Which two angles are congruent? So if 4 is supplementary to angle 6, and 2 is supplementary to angle 7, but 6 is congruent to 7, so 6 and 7 are congruent. What else is congruent? Don't overthink it. Don't overthink it. Yeah.
Angle 4 and angle 2.
It's angle 4 and angle 2.
But you don't know that they're like congruent. They just have to equal. They have to be. They're supplementary. Doesn't mean they're equal.
Right, okay, so if angle 4 is supplementary to angle 6,
Yeah.
and angle 2 is supplementary to angle 7, but 6 equals 7, okay? So let's say 7 and 6 are 40 degrees. So if this is 40 degrees, angle 4 has to be 140 degrees, right?
Yep.
Well, that means this is 40 degrees, which also means this has to be 140 degrees.
Okay.
Do you see, if these are the same numbers,
Then the other
these also have to be the same
so
numbers.
You could say that measure of angle 2 is congruent to measure of angle 4.
Yeah,
Oh.
Yep. that's...
Is that okay?
Yep, that's perfect. No. And I'm going to tell you right now, you have a theorem, just like 2-8, but that's with supplementary instead of complementary. So there's a theorem that works just like that one. Yeah. 2-7. That's okay. As long as you make it through this class. Just don't die in this class. It's a bunch of paperwork. You have no idea how much paperwork I have to fill out if someone dies in my class. And 2-7 says if two angles are supplements of congruent angles or the same angle, then the two angles are congruent. All right. That pretty much does climb. We have a couple minutes left, so what I want you to do right now is just look over your homework. If you have your book, make sure everything looks in order. I do want to bring up too, because it was brought up in class that some of the answers, especially the proofs, aren't on that short answer guide. But remember, I also posted the solution straight from the book. All right, so if it's ever not on that solution guide, check the book solution guide because everyone's on there. And the proofs are nice because they're set up as the 2-column picture things.